Hello everyone, and welcome to the last Lightning Talk under Code Week Training Webinar Series, which included sessions designed to inspire educators and teachers with fresh ideas and practical approaches to coding and computational thinking in classrooms. For your information, this session will be recorded and uploaded on Code Week YouTube channel, as I said before, as part of our training material. Today's Lightning Talk is titled NerdKunst, a gentle and interactive introduction to generative art, and it's co-organized by All Digital and CoderDojo Belgium. Our speaker, Nick Boucart, Senior Technological Advisor at Sirris and volunteer at CoderDojo, will introduce us to the world of computer-generated art through live demonstrations and interactive exploration. Using freely available open source tools, the session will show us how anyone can start creating generative art. It will also highlight how this practice can serve as an engaging way to learn coding and to explore mathematical concepts in a fun and accessible manner. For the agenda for today, we will first start with a 20 more or less minutes presentation from Nick, and then we will move to a 5 to 10 minutes Q&A. So please either feel free to join us at the end of the session for the Q&A itself and to speak up, or you can always write your comments or questions in the chat, and I will collect them for the discussion at the end, so as you feel more comfortable with. And now I can definitely say that Nick, the floor is yours. Thank you.
Okay, thank you for the introduction, and thanks for being here all. What I hope to give you as a message today is that playing with technology and playing with code can be fun and beautiful too. I call it NerdKunst, which is Dutch for nerdy art, I would say. And let's start with an example. Imagine you do an experiment where you toss a coin, and if it's head, you write a forward slash, and if it's the other one, you write a backward slash. And when you do that, you get a special kind of picture. This is a live generated example of such an experiment, right? You'll see patterns emerge, some interesting things emerge, and that is by having a simple algorithm for each section of the image. I toss a coin. If it's head, I do a backslash. If it's the other one, I do a forward slash. I find this very, very fascinating. This, by the way, is a famous one-liner. I didn't invent this thing myself. For the record, I consider myself more an educator and an enthusiast than I consider myself an artist in this matter. This is a famous one-liner, the 10-print one-liner. There's actually a book written about it. This one was first developed in the 80s, in the time of Commodore 64s and Amigas and so on, when it was like a meme to come up with one-line, single-line programs that did something interesting. And this was one of them. Today I'm going to talk about generative art. What is it? Generative art is a form of art where an artist develops some kind of system, in this case, a computer system, some code, and that system autonomously generates artworks or installations, becomes an installation that does something interesting. And I hope in this presentation to give you an idea of what generative art is, and especially give you some inspiration to use it for educational purposes, whether it's learning to code or visualizing mathematical or physical concepts in a fun and very accessible and playful manner. If by the end of this session, at least one of you has the tendency to say, I want to play with it, I think my mission here is done. It's not new generative art. People have been doing generative art for a long time. I just give you two examples of people that are, let's say, a bit instrumental in that field. Vera Molnar was a Swiss-Hungarian artist, and she was one of the first to make these kind of to develop programs, basically computer programs that generated these kind of pictures, which is a form of art, right? Another one that I really want to mention in this case is Sirris. He is the developer of and the developer of the processing programming language, which is a programming language specifically designed for creating generative artworks. And I'll be using a derivative of his work in the majority of my presentation. Here you see a couple of creations of him. Of course, everybody today can be a generative AI artist. If you just prompt any large language, any online model to do to generate images, of course you can create your own imagery. In this case, your algorithm to develop it is the prompt, but I'm not going to go into too much detail. This is not what we're talking about. We're talking about really writing your own code to make concepts alive and to make art come alive. There's multiple ways to present your work. You can print or plot your generated images. That was what in the beginning the pioneers did. You can have a digital photo frame where you see your work scroll by. You can even have interactive installations where your installation via webcams and other sensors interact with the audience, all the way to live coding, where people really live in front of an audience alter code and alter code and alter the art. I'll give you examples of all of these in the next of the talk. In the end, what I really like about it is that you express yourself through code. Not everybody is good with crayons or with paint or whatever. Code can be a very, very, very nice way to express yourself as well in an artistic way. It's very visual. It's a fun way to explore programming and algorithms. And it's somehow a combo of computer science, art, technology, which I find personally educational and fun. It's fun. You see immediate results. And for me, that really works. Now, you don't have to take my word on it. The next part of the presentation, I will show you hands-on how it can be done, how it works, how you can fiddle with it. This is the boring part where I give a bit of theory, and the rest, most of the other things will be practical. In generative art, there are a couple of key concepts, and in my next slide, I will start exploring them together with you. There is the artist, in this case, me, who wants to do something. I create rules, algorithms, basically code, that tell the machine how to generate the art. Typically, not always, but very often in that code is some form of randomness, which means that the results are, in a way, a bit unpredictable. Oftentimes, there is repetition, patterns, these kind of things that somehow emerge then. And the emerging image is something that provokes emotions. Now, let's make this concrete. Okay? This is this famous one-liner again. You see here the code. It's like only 22 lines of code, so that is not so hard. And you can start playing with it. If I make this orange, yeah, you get already a different look and feel. You could make this blue, and you start seeing it's always a similar image, but it provokes a different kind of emotion. It's different. What would happen if we make the size a bit smaller? So then we get, if you say, okay, a bit larger, the size of the backslashes and forward slashes is a bit bigger. Similar view, but different. By the way, since there is randomness here, every time I run this code, I get a similar image, but it's a unique one. The chance that you generate the same image twice is very, very small. What would happen if I make it 8, for example, very small. Then I get this kind of patterns. Again, the algorithm is more or less the same, but for me, this has a bit of a different connotation, right? Let's make it 20 again. What if we would use a dice or a coin that is a bit biased to do head more than tail? Then you get something like this. Now, most of the decisions it makes is to put a backslash rather than a forward slash. You can even do it more 95%, for example, and then you get something like this. Is this interesting? I don't know, but it gives you an indication of how you can influence the work, influence the algorithm. You could even make the lines a bit thicker. And again, it's all very similar, but yeah, for me, I can play hours with this. The code is here. You can play with it. It's interactive. No need to try. You can immediately try it out. Before you say, "Yeah, Nick, but this is all very expensive and difficult and blah blah blah," all the tools I use here are open source, so they are free to use. I use P5GS, is the JavaScript library behind what I'm doing, and I will later on have a bit of an example in strudel.cc as well, which is then more for music. If you are into music, Sonic Pi is also an open source project that is often used to do live coding, live programming music. Voila. Now, let's get us started. This is P5GS. It's a very accessible website. They have an online editor as well, so you don't need to install anything. They have super cool tutorials, references. The whole library is very well documented. And voila. I really like it. If you want to start with it, there is a gazillion tutorials online where you can find examples and inspiration. And you can even use other JavaScript libraries. I will have an example later on where I incorporate a bit AI into a project as well. Okay, let's give some examples. Let's try some things. Voilà. Let's try with some basics. A basic sketch in P5 has a setup and a draw function. That's all there is. In a setup, you create a canvas. This is basically your canvas that you can paint. In this case, you give it a background of green. I could also make it blue, and then it's a blue canvas. Wow. And there's a draw function. The setup function is only run once when the program starts. The draw function is called like 30 times a second and allows you to do other stuff. Coming up with putting basic shapes on there is as simple as saying, okay, I want a circle. This is the circle. This is the position, and then the size of the circle. I could make this 20, and then you'll see the size be a bit smaller. You give it a color. You make lines. You do rectangles. In this case, I do no fill, which means it's not filled out. And voilà, that's how you start to do basic shapes. Movement. Movement. Let's make this a bit smaller because this is a bit slower. Movement means that in the draw function, you I had to do this one. That's slower. The draw function is, like I said, is called 30 times second. In this case, every frame is built by making the background black again, drawing an ellipse of a certain size, and I do the size a bit. I make the size a bit smaller, and then you get the illusion. You build movement in. These are the basic building blocks of any P5GS script. Let's start to do some more interesting stuff. I told you about randomness. This one is a canvas where we split the whole thing up into a number of squares, and we randomly fill it by color. This is, to me, a bit chaotic. It's not really nice. this is scale. It would be cool if the randomness was a bit more ordered. And the cool thing is, there's functions for that. It's called Perlin noise. There's a noise function, and here you see a bit of randomness, and it's a bit of a special pattern, but there's a bit of consistency as well. The Perlin noise is a pseudo random function that takes in parameters, and it will produce the same value when the same parameters, and it will produce when the inputs are close together, the outputs of the function will be close together. And if I run this again a few times, you see this is more interesting. If you would then this is a similar thing. You per pixel you ask it a noise value and you check whether it's between certain borders, and you give it sand, water, forest, or grass as colors, and you get something like this, which looks like an infinite landscape. It can even be more interesting if I change this one to minus frame count divided by 50, and I comment out this line, and if all goes well, you get this kind of thing. So now with only a few changes, you get this infinite scrolling procedural landscape, which is fun to watch for hours. It will never ever be the same. It will be similar, and each time I run this, you will get a similar landscape. If you want a bit more water or a bit less sand, you change these values, and you will see that there is more forest, more land. This reminds me a bit, and it gives away my age a bit. I used to play on arcade machines, the game 1942, where you had went over a small thing. Mathematical concepts. This is cosines and sines. I mean, it's the projection on the x-axis and the y-axis. This to me, I find this very visually appealing to understand when sinuses become negative or when cosines become negative or positive. I find that fun. But why stop there? We all know the first formula. That's the unity circle. But what if we would change these values? Let's try that. This is the unity circle where you use the cosine, but let's change it to 35, for example. So make sure that we see that it's not the cosine and the sine of the same angle. It's a bit different. Then you get these kind of patterns, which are, again, I find this interesting to see. You can play with it. You can guess, is it an open figure? Is it a closed figure? This one is a very complex one, and sooner or later it will close. It will come back to the original starting point and have something like this, but you could make it 27, for example, and then you have, again, a very different kind of pattern. This makes cosines and sines, or at least in my opinion, a lot more visually appealing, right? Let's talk about exponential growth. That's something that comes back in physics a lot. And I think in physics a lot, that comes back in physics a lot. Exponential growth means you do ×2 every iteration. Well, this is a firework where every iteration there is double the amount of arrows being thrown away. And you see, while in the beginning the firework was a bit boring with one thing, very quickly it becomes like overwhelming. This is exponential growth visualized, not in this typical curve that goes up and to the right, but in a different way. I talked about AI. This one is not even 100 lines of code, where I use an open source body posture detection. It's called Body Pose Net. It's an ML5 library, open source, runs in the browser, and it detects my ears, right? I see me moving. And in P5, I then generate some steam out of the ears. I have an installation where this is with a webcam and people come in front of it. It's always fun to see what happens when kids and their mom stand in front of such a picture, and then the steam comes out of the mom's ear. Very very happy, very funny to see. So if you like P5, if you like what you're seeing, I really encourage you to go to p5gs.org. That's the main site where you find it. I also encourage you to look at the site the Coding Train and their YouTube channel. You find there tutorials, super cool done. I'm very jealous. I'm very jealous on how they do it. Very nicely done. And I myself have a little side project called NerdKunst.be, where I also write some tutorials in Dutch. To wrap up for today, let's do some music. I did visual things before. It was visual art, but you can also use that to generate music. This is done with an open source project called Strudel. This also runs in the browser, so nothing to install. It can be done very quickly. And I'll go quickly over how I give quickly an example of this. It can start out very simple. So it's interactive, it's live coding, it's very fun. There's all sorts of things you can do. You can stack notes. You see there's different sounds, there's a piano and electrical guitar. Strudel comes with a lot of these instruments and synths built in. And you can make them longer or slower, the notes. Was an acoustic bass. You can create. You can do alternate notes. And if you then bring it all together, you can start to build your own music. Now, if I run this does nothing for the moment. So let's add in the bass. I encourage you, if you recognize a song, put it in the chat. If you would recognize the song. By the way, all these examples in Strudel come from the official documentation of Strudel. I'm not so good with music that I could produce this entirely on my own. I just wanted to show these things as examples of how you can use programming and use development and code to come up with new forms of art. Which brings me to my last slide. I hope I showed you very quickly that generative art and programming art can be a very fun and interesting way to learn new concepts, to learn to program, but also to learn some science and some mathematical things. If you want to reach out, you can find me as Nick Boucart on LinkedIn. That's probably the easiest way to find me. Thanks, CoderDojo Belgium for bringing me in contact with this nice initiative. Thanks for my employer, Sirris, for letting me use their offices to do this in between other meetings. And yeah, that was it for me. Are there questions? Is there remarks? Uh,
I think that we were all so impressed by all of this. There's like, wow, I've never seen such a thing, both in terms of like visual art and like music, which is also an art. So really, congratulations to develop such a code and to also to the clarity for explaining us and how it works and how teachers can potentially implement that to approach students in their
thank
classroom.
you.
We have actually a couple of questions in the chat. First is where Monia can find examples like this. I already replied with like the links to the tools that you used, but
Mhm.
maybe there's like an online resource where she could find these codes, or I'm not sure if you could.
What I really would encourage is to go to the website of the coding train and to their YouTube channel. That's a very nice start, a place to start, especially also for educators, because that guy is really, yeah, is not only showing the examples of what is possible, but also shows how you he shows computational thinking as well, and his thought train, his train of thoughts, and how he comes from. Okay, I want to do this. Okay, let's break it down. How could I build an algorithm to achieve that? Um, yeah, it's very well made, very well produced. I'm a big fan of that one. It's a
Thank you
very
very
good
much.
start.
So it's the coding train on the
Yeah,
YouTube channel. Okay,
yeah.
great. Perfect. And then we have another question, which is if there's an online playground to try it out without having to write the code itself.
Well, on the website of P5GS, you find a lot of examples, and if you some of them, if you open them, they open in an online editor. So the code is already there, and you can start exploring from there. And that's typically how it starts. Um, you can open any project. You start with that, and you start to tinker. And it's the tinkering and the immediate feedback that gives learners a lot of possibilities. And then later on, once you are a bit fluent in that coding, yeah, you start to come up with your own ideas and to wonder how can uh, yeah, and then to start developing your own little sketches and programs and stuff.
Very nice. I actually have a question myself.
Mhm.
Is it possible to like put together these different kinds of art that you showed us, like potentially having like a visual art piece of art with the music on top of it through coding? Is it something that is
Of course,
possible or
everything is possible.
everything is
In
possible?
the end, this is just code. This is just I just this is a bit of code. This is a bit of if I can do this, anybody can do this. And it's up to your imagination and then a bit of fiddling and trying out. And I mean, yeah, and you will learn a lot. You will have a lot of fun. Every now and then you will be a bit frustrated because you will run into some strange behavior, which is typically for coding and life in general. So voila. Um, yeah, you could have the music on top of next to it. Yeah, that's all. It's all possible. By the way, in P5GS itself is also a very nice sound library. It's not as elaborate as the one I showed with Strudel, but there's also a lot. There's also things to manipulate sound and to create either synths in there as well. So yeah, if sound is your thing, you can also do that in P5.
That's very interesting, and thank you for sharing all these like repositories and resources that our audience can use in the future. It was fun when you mentioned before that you could do this like all day long because it's so fun and engaging that literally you could play with this all day long, and I think that like potentially also for young students it could be something really interesting to approach them to coding because if it's something is fun, and we had like in the previous lightning talks we had some fun interactions, let's say, with coding, so that it can be easier for people to be approached to this word, let's say, because
Mhm.
it seems scary, it seems complicated, also to me, it seems difficult. But then, if there's a way to make it funnier and easier, you at some point I think you can realize that everybody is able to do it, and it's not that complicated. I mean, it can be super complicated, but in the end, it's some basics are quite easy to get.
Well, yeah, true. And when I talk to when we do our dojos with our kids in CoderDojo, we also say, look, Fortnite isn't built in a day. Eh? That's something you start with something small, you build on top of it, you build on top of it. By doing it, you get some more ideas, you build on top of it, and you build on top of it. That's how Facebook is made. That's how Netflix is made. That's how Fortnite is made. That's how art is made. In this case, that's the whole idea of coding. You have an idea, you take a small step, you try it out, you fiddle with it, you get new ideas and build on top of it. And I think having the immediate feedback in combination with something very visual is super can for many people it's just very engaging.
Indeed. I mean, in the end, it's all about learning. It's a learning process. So it
Yeah.
requires some time and some patience, but you can get there.
Well,
Um, I think I mean, I'm now asking if there are any other question. I saw that someone just joined. We're almost at the end, but you can see in the chat some previous questions that were made, some resources, some websites, some tools that you could approach to get an ease with coding in the world of art and music in this case. So I'm now asking if there's any additional question. Otherwise, I think that we could also wrap up. I think there are no questions. So, since this is the last Line and Talk of this webinar series, I would like to deeply thank Nick and also all the other speakers from the previous sessions. It has been a real pleasure to host such interesting sessions, such interactive sessions, showcasing a different number of tools and innovative approaches that could really help teachers and educators in general to integrate coding and computational thinking in their classrooms and to make kids, students, learners more closer to the world of coding. And also thanks to all of you who attended this lightning talk, the previous ones. There's gonna be hopefully some others in the future, but for Code Week, it's a wrap up. So happy last days of Code Week, which will end on the 26th of October. And you will find all the recordings, as I mentioned, on the YouTube channel of EU Code Week. So that you can see and re-see all the presentations that our wonderful speakers had shared with us, and all their like explanations, and everything is gonna be there. So thank you very much, and I wish you a nice day ahead.
I
Bye bye.